Hello, MotoAmerica fans. Welcome to this latest edition of Off Track with Carruthers and Bice. We are here at Road America this weekend for another round of our series, and it's actually round 3 for the Parts Unlimited Talent Cup by Motul. Paul and I are really excited to be joined here by Joe Karvonen, who is the CEO, the founder and owner of Krämer Motorcycles U.S.A.
Mm-hmm.
Sorry about that, Joe.
Okay.
I'm just so impressed that at such a young age, you got... That's impressive, your title and what you're doing. How did that come about?
Well, I've been in the motorcycle industry all of my life, and was into road racing, of course, and had a couple customers here in the North American market who found out about Marcus Krämer very early on back in 2013, 2014, and ended up importing a bike just kind of by happenstance. And it sort of snowballed from there. So we started in 2015, kind of softly, 2016 in full gas, and we do quite a few bikes now. It's definitely really ramped up quickly. So went from importing a couple motorcycles and seeing what we could do to developing that bike quite extensively with Germany, and then from there growing into Krämer U.S.A.
One of the things I love about those bikes, and if you guys know the line, they have several different models with different size engines in them and different sizes of the bikes too, but they have a pretty specific design language. I mean, it's a trellis frame. Do all of them have the gas tank under the seat? Yeah,
that's kind of one of our, design features that we try to stick with. So our fuel tank and our subframe are both the same component. It helps, one, move the weight lower in the chassis, but also, it's anytime you can make one part do two jobs, it's always a benefit. So it's sort of a unique thing. We have that both are on all three of our families of bikes: the GP2 family, the Evo family, and the Apex family.
I like the way you took something that has this appearance and kind of an aesthetic to it, but it's kind of form follows function a little bit, right? I mean, like you say, there's a reason for the tank to be where it is.
Yeah, it's of course it creates a fuel mass slightly more rear bias, but since we don't need a full fuel tank most of the time for a lot of the sprint racing, your fuel is actually surprisingly centered in the chassis due to the shape of the fuel tanks on our bikes. So you really do gain a lot of benefit out of moving that fuel mass lower by as much as 6 inches central in the chassis. So it helps a lot.
All right, so I'm going to put you on the spot for a minute because I'll tell you, I've been around motorcycles long enough, featherbed frames with tube frames, steel tube. For a long time, Ducati had a trellis frame, and then a lot of formed sheet perimeter frames, extruded, all kinds of stuff. And I thought, well, the steel trellis frame is not something that people would even do anymore. There's got to be something about it that's beneficial. What is the deal about a steel trellis frame?
Well, it's called a multifaceted. There's plenty of great technology in aluminum or carbon fiber now. There's a lot of technology that can be done with that. It's great. But it has its limitations though too. You are very limited on some of the structural aspects of it through trying to find packaging solutions and things like that. Whereas a steel frame, we can do different wall thicknesses and even butted tubing where it's tapered internally. So that way we can get flex characteristics in the center of the tube and strength at the ends of the tubes, things like that you can do with steel that you can't do as easily, at least with aluminum or composite materials. So it's some of it's simple, and some of it's also being very strategic in how we can add chassis flex with different wall thicknesses. And that's really the main thing, is we can play around with the frame and have maybe our upper spars of our chassis be a thicker tubing, our bottom spars be a thinner tubing, or our cross spacing be a different thickness, while carrying the same OD on all of it for both aesthetics and welding and fixturing reasons. So it's a very versatile way of designing a chassis and executing on a chassis design.
Excuse my ignorance on the company, but I'm correct in thinking they're only track bikes, right?
Correct. Yeah, we don't build a street bike. We always find starting as a street bike and trying to build a race bike is in our opinion, the wrong way to do it.
So it starts out from day one as a race bike and nothing else.
Yep.
Now, is there people like to do different things, but is there a way that a guy could buy one as a track bike, but then somehow make it street legal? I mean, that's not something you would recommend, but do you make it so it's almost impossible?
Yeah, I mean, anything's possible. Obviously, the regulatories they have their roadblocks that are in place on that, and we respect that. But it would not make a great street bike.
Yeah.
I mean, if you're going to go to the canyons and you're going to do that kind of stuff, okay, yeah, sure.
Yeah,
but,
and I think it's cool. I think the whole concept of having a track bike, especially nowadays, track days are more popular than they were in the past. So it gives a guy an option. He can buy that and he doesn't have to do anything, right?
Yeah, it's turnkey. I mean, that's the whole focus of our company is building turnkey race bikes. I think that's something that not many manufacturers focus on anymore. I think historically, when you look at some of the bigger OEMs, other than us, such as Yamaha as an example, building the TZ family through the years, it's been done. Other companies have done it, and I've always been sort of surprised that it's been something that they stay so far away from now. But we believe in this space as a market, and we've proven that there's a demand for it, and so we deliver, like I said, 3 different model ranges now to help make a solution for kind of every buyer.
So how did the relationship get started with MotoAmerica now that you become the bike of that class?
It's like a right place, right time, type situation kind of kicked in a little bit. It was industry colleagues kind of heard that MotoAmerica was looking at different ideas and stuff like that. And we had already gotten beyond napkins sketch with the Apex family. It was a very different bike in a lot of ways than what we deliver now. MotoAmerica had some standards or some design goals that they wanted to reach with electronics and also with some of the tire choices and things like that, which were all fine, but we had to kind of go back to the drawing board a little bit on certain aspects. But at the end of the day, it was just we kind of heard through the grapevine and said, hey, here's this thing we've been working on. We've been doing some testing already. And they're like, yeah, great. We want to do that, but do all this differently. And we're like, okay, that makes a better bike. It doesn't, make it easier, but it makes a better bike. And so we went back and applied all the higher spec electronics and things like that they wanted to see. And
which I think is cool.
Yeah.
I think it's going to help these kids a lot to work with something more advanced.
It is.
At an early age.
It is. And I think it helps, I think, it'll help teams that have been reluctant to working with data. I think it's kind of stronger in them a little bit into like, hey, looking at your data is important. Having stroke sensors isn't some fancy thing now. It really should just be another tool in your toolbox, and it needs to be looked at that way, where these things like brake pressure sensors and stroke sensors and things like that need to be looked at as a tool and not as this black magic that I think it's perceived as. And in my opinion, data can be as complicated or as simple as you want to make it. And so especially companies like AIM or 2D, which our bike is open, you can use any data logger you want. So if you prefer AIM or you prefer 2D or whatever, you can do so. It just plugs in and you just have to have the right protocol. So it's not a big deal. But we have AIM as a technical partner, and same with 2D, and so there's solutions for the Apex that are plug and play and very simple in that sense. So
let's talk about this series a little bit. So, I mean, I don't know if you're one of like a duck that on the surface you can't tell, but underneath your legs are going like a mile a minute. But I'll tell you, going into COTA, I was pretty nervous. I was like, oh my gosh, these guys are going to debut this bike on the biggest stage of all.
Right.
And it went beautifully.
Yeah. It went really well. It was a lot of work to get there.
Yeah.
It was a lot of work to get there. Yeah. I mean, this is the first product we've ever taken from design conception to delivery and usage pretty much immediately. We build production bikes. We've done that. That's not a problem. It's just, the first few, you always learn something. And we had that, to be honest. We had issues that at the end were, they were just assembly problems or machine, not necessarily that's the wrong word to use, just things that unforeseen. We've narrowed down. We had some valve issues that were all publicly known.
Yeah, went from steel valves to titanium valves. Made a huge difference.
And
there wasn't a lot of engine failure. It just one or something.
Yeah, we had an engine that failed, and we were trying to figure out why. And in the end, and it's the jury's still out a little bit, but I think we finally narrowed it down to to assembly lube, actually.
Wow.
Yeah, which is something that I never could have pegged it on. But yeah, no, we're still working on the chemistry. We're actually talking with the supplier on that when it comes to valve train assembly lube. But we noted that upon disassembly on all of the exhaust side, is the issue we had, that the valve guide, the valve stem was sticky, is the best word to describe it as. But there was a notable residue and a notable drag upon disassembly on all of them. So we don't think it actually was a metallurgy problem. We don't think it was a weight problem. We don't think it was a spring problem. We actually think we've narrowed it down to a assembly lube issue.
Wow,
which
that's
these are the
incredible.
things. These are things that in manufacturing, you build an engine in your garage and whatever, it goes fine. But when you suddenly build 40 of something or 100 of something, and you have one thing like that, it suddenly turns into a big problem. And something that was not where my mind was. I was fully convinced that we had a metallurgy issue, but no, it's narrowed down to that at this point.
Yeah, and again, it wasn't anything super major in terms of, it wasn't like catastrophic to a number of bikes.
No.
So I want to ask you about that a little bit specifically. It turns out maybe it's not the fact that it was a steel valve versus the titanium. You pretty much are saying that.
Yep.
So what would happen? Is it at high RPMs you were getting some valve flow and it maybe piston to valve contact?
Correct. Yep. That's what it was. We were getting valve flow on the exhaust side, and it was something that we were convinced that it was potentially a valve weight issue, because the RPM was fine in testing. We never had an issue, and it's obviously that's everybody says that in testing never is an issue, and not necessarily wasn't. We still have one of the development bikes here on display this weekend with over 2,000 race kilometers on it, with the original steel valves with no issues. So we are very confident that the material type isn't the issue, and the weight of the valve isn't the issue, and the valve stem to guide clearance, like all the technical stuff was fine. We still believe that. And we actually have a bike we've been testing, and only brand new engines that are with steel valves have the issue. All of the ones that have survived for a long time don't have the issue. And the part is exactly the same. So
wow.
So yeah, it's a very odd one to run into, but yeah, we decided, since we couldn't give a clear answer of why we had the issue, we immediately shifted from the stainless valve to a titanium valve, not because we needed to save valve weight. Now we know that for sure, but it was just a safe decision to make. It was a hard decision to execute, to be fair, because we decided to make these changes 2 weeks prior to the Crescent test.
And I'm not going to point this out as being a mistake. What I'm going to say is you guys almost overcompensated on it. You went and proved more than you needed to.
Yeah, we tried to, because it was just one of those things, like, if we're going to fix the problem, let's really fix the problem. And we did, a lot of people asked why we did stainless valves instead of titanium valves, and we did it for just cost effective and durability. Stainless valves always going to be more durable long term than titanium. Obviously the engines can rev a little bit freer. There's a little bit more power there. There's no negative necessarily, but long term, the titanium valve will have a shorter service life than the stainless one. Well, we know that, but there was an educated decision behind doing the stainless valves, and then in the end, going with titanium. There's a sound reason behind it there too. So yeah, that's kind of the very long walk on that one. But we wanted to make sure we fixed the problem correctly, and addressed it as rapidly as possible. And so yeah, it took a lot of people involved, from people at KTM North America, KTM Austria, Krämer HQ, along with our whole staff, to make that happen. And it went pretty smoothly. We had a couple bumps in the road, but in the end, nobody missed any race round or anything like that because of it. And that was pretty much a full recall, honestly. Was about 2 to 3 weeks to race one.
Incredible.
Yeah. So yeah, these are the things you learn in manufacturing that you just could never really predict. To be put on such a big stage as you mentioned initially was, I'll use the word terrifying, because I think it was the best way to describe it. When we were standing at hot pit wall on the initial green flag start at Coda for race one, it was like, well, we'll see what happens here. And all was well. We've continued to update things that we find along the way, and we're continuing to work on stuff with our team in Germany, and also our technical partners with Soul Engineering and guys like that to help keep advancing certain points of the bike, but how we're off and running. So
it's incredible.
One of the things that concerned me about the class when it was introduced was the fact that, like, I wondered, with the bike having so much adjustability, with the electronics, with the chassis, all the stuff that they could do, that like the young riders that were able to go with a team with an experienced crew might have a huge advantage over somebody with maybe their dad and going down rabbit holes. And have from the outside looking in, I don't see that, but has that been an issue? Like, without naming names, is there dads that are like, hey, we need help?
I don't want to throw anybody under the bus because I think everybody's putting their best foot forward. I don't want to say that, but I will say that there is a definite noticeable delineation between the more experienced teams that have previous experience with electronic, the ECU software, or with Soul Engineering parts and pieces and stuff like that. So some of your next gen teams and things like that, they definitely noticeably have more experience. So there is some teams that are kind of getting down some more straight lines, I would say. One thing I'll say, my job isn't to tell them how to do it, though, necessarily. I'm here to help. I might make suggestions, but I have to kind of stay on as neutral as possible, because I want to make sure that it's fair and it's the rider and their team trying to get across the finish line first. And of course, I don't want to not help, though. So if somebody's struggling, somebody's having a hard time, somebody's having an issue, like, come find us. That's why we're here. I'm not driving to each round just to stare at the ceiling.
Yeah, and I don't even think the other teams would be upset about you giving some help, because they want to see everybody have some sort of success.
Exactly. And that's what I hope. I want to make sure the sportsmanship is solid, and so far I think it is. I look throughout the paddock and I see, opposing riders giving high fives and and poking fun at each other and stuff, and it seems like that side of it's good and strong, and that's where I want to keep it. I want to make sure that the teams know we're here to help, and that's our goal. So,
yeah, I mean, one of the coolest things about Talent Cup is you guys are Krämer Motorcycles U.S.A. Krämer globally, and the other manufacturers that are in our series don't really have a problem with putting their logo on a Krämer motorcycle.
Yeah, that's what makes it really cool.
It's very cool. And the fact that we've got our teams involved in it, from HSBK, Ducati, Eston and Yamaha's involved. Honda's got a couple bikes involved in it. And that's a real cool branding exercise for them.
It is. Yeah, we're extremely excited about that. As a fan of all of the other OEMs, I mean, I'm a motorcycle guy through and through. So I get pretty giddy seeing a Blue Crew logo on the side of our bike. Not because I want to toot our own horn, but honestly, I'm excited about that. And same with Honda and Ducati and anybody else who's in the game or wants to jump into it, because we encourage more, obviously. But yeah, it is cool. And I know it takes an army to execute on those things. And so we're definitely grateful and excited about that, for sure.
The other thing I want to ask you about a specific rider, Julian Correa. So last weekend, he's racing in British Talent Cup. He raced last weekend at Silverstone. They use a Honda NSF 250R. This week he's racing in Talent Cup on a Krämer APX-350 MA. Have you ever talked to him, or has he ever said anything about the comparison of those two bikes, or do you know the comparison of the two bikes?
Yeah, we spoke a little bit briefly. The first two rounds were such a whirlwind that it's been tough. But one of the things that's interesting compared against like the NSF 250 versus the APX 350 is they are very different bikes. One of the things that we set out from the beginning was not to build a Moto3 bike, which I know sounds contradictory, but we know the limitations of the NSF. It's a very developed chassis. It's very good. I'm not going to give any negative to the bike, but one of the limitations of that family of motorcycles in general is the physical size. If you take a rider like Cody Kopp as an example and stick him on an NSF, we're going to have a problem, because he has a hard time fitting in our bike, and our cockpit is easily, I would guess, somewhere around 50 millimeters longer than an NSF chassis. So for some riders, they would fit in just fine. Obviously, they would wedge right into that NSF, no problem. But when you stick them on to, an NSF and they're 6'1", 6'2", as some of our riders are here, that becomes a bit of an issue. So the whole bike is physically larger. It's physically heavier because of the scale. Plus, we're obviously trying to use some more cost-effective components when it comes to drivetrains and other parts to help keep the cost down. So there's some performance differences there. But yeah, it's a very different bike. Now the general concepts, obviously, race bike's a race bike, and we know that geometry is different, but it has to be. It's a bigger bike, it's a different bike, different packaging. So it's a complicated thing. Like, I can get super nerdy about it, of course, but at the end of the day, they're a bit of apples and oranges. But the idea behind it is to educate a rider on how to set a bike up, how to prepare them to understand how to identify the differences. Because when we were working on development, one of our test riders has experience on GP bikes. It said, it doesn't feel necessarily exactly like a Moto3 bike, but anybody who's on a Moto3 bike jumps on a Moto2 bike, and they're not expecting it to feel like a Moto3 bike. So it's not designed to be a one-to-one. It's designed to be a transitional tool. So, yeah.
The other thing I want to talk about is comparing it to Junior Cup. So we had the KTM RC Cup, and it was a spec series with a production street bike, and then Junior Cup we opened it up to other manufacturers. It kind of became a little bit of a Kawasaki Ninja 400 spec. There were a couple of Yamaha R3s left in there, but now we're doing this, and as I recall, and what I've seen so far, the lap times have been faster in Talent Cup on your bike than any of the lap times in Junior Cup.
Yeah, so far we've seen them be quicker, and we anticipate them to be quicker. Especially the more technical tracks. The more technical tracks, you're going to see a bigger delta there. The bike is quicker in the corners. It is faster all around. Here it'll be interesting. I think the lap times here will be a bit closer. This is a more unfavorable track when it comes to that, because we're approximately 50 horsepower at the tire on the 350, and the function of speed is mostly aerodynamics. We are fairly aero, but 50 horsepower frontal wind load of a motorcycle, it goes so fast. And so we know that the lap times here probably be a bit tighter, but we do anticipate, especially on the backside of the track, where we know the sectors back there should be quicker. So I think we'll go a bit quicker, for sure. We've been consistently a bit quicker. Where's the benchmarks? I'm not really sure, to be honest. We'll see as the seasons progress, but I think we're seeing it already. Some of the riders, obviously we can't repeat the tracks exactly in the same scenarios, but we're seeing them get quicker in general too, the riders themselves.
The corner speed's got to be quicker on your bike.
Yeah. It is. Yeah, for sure. The corner speed's definitely quicker, and you go fast in the corner, you go faster everywhere.
Right.
These big straightaways here, they're going to be interesting. So that's a little bit different animal. It's kind of like Coda. The back straight, you're going to go so fast at some point. 50 horsepower is 50 horsepower.
This track's just like a dyno, right?
You
might as well just be on a dyno.
Yeah, it is. It's just the straights here are real, and that's fine. We have confidence in that, but it is one of those things where we know the bike's gonna go X amount of miles an hour on the top end, because that's how much air we can push with 50 horsepower. So
why do you think it was Road America was chosen for a round at Talent Cup?
That's a good question.
Yeah, I mean,
I love Road America.
Yeah, we all do. Yeah.
I think it was probably to showcase the class in front of one of our biggest audiences, to be honest.
Yeah, it's a great facility. It's a great track. I love coming here. I've been here for many other events, and it is one of my favorite. Being here and being at Coda is a little bit of a head scratcher from the bike's perspective, but on the flip side, I'm okay with it. Both of them are amazing facilities, and the crowds obviously at Coda were amazing.
Yeah, it's like weighing the exposure versus the pain in the ass factor.
Yeah. And it's going to be good racing regardless. So they're just going to spend some time on that throttle stop is all.
So I want to get technical with one thing with you, and it's because of a bulletin that recently came out, and I'm sure you can speak on this. I've spoken to Teague about it, so I'm up to speed on it. The bike was 110 kilograms. Now it's allowed to be 113 kilograms. Did something get added to the bike? What changed? Where's that 3 kilograms? Where did that come from?
Mainly, there's kind of two things in that. One, production weights versus testing weights always vary a bit. So we ended up a touch heavier, and some of that's body work, some of that's plastic thickness in the rotor mold on the tank, things like that. You can find a pound here or there pretty quickly. So there's some stuff like that. Tire weight is the thing too that became a factor because our test tires and development tires ended up weighing different, things like that. So like there's a bit of a stack up there. The other thing that we noted too was we're just comparing all the bikes. Some of it's also weight of bodywork, paint, decals, things like that. So seeing that drift and that slight increase across the board, it was Teague's decision to try and level the playing field a little bit easier and a little bit better. And I think that's right. The other thing that's interesting too with our bike, the actual dry weight is different than the what I'll call it a drained weight because of our fuel tank shape. Some fuel gets trapped on the left side of the tank because of the shape of the tank. There's a clearance for the shock, so the fuel cell has a hump in it. When you go around the track, it's not such a big deal, but if you just gravity drain the tank with our fuel tank drain that we have integrated in the fuel pump module, you don't get the fuel that's on the other side of the tank. There's another half a pound of weight there alone. So things like that sort of just creep. And so in the end, we decided after weighing all the bikes here and their kind of final livery and final configurations and looking at our manufactured weights and stuff like that, that was kind of where they want to settle at. And I think that's fine. I think it's good. So.
Okay. By the way, Joe, that's exactly what Teague said to me too. It was it's more you've been more accurate about it at this point. Not that you weren't before, but I'm just saying. You know, it was a little bit of a guess.
It was. Yeah, it was. You know, we had to we know what all the parts weigh.
Yeah.
But you know, all it takes is somebody to be a little more heavy-handed with the the fiberglass that day, or a little bit less, or a little bit of this, a little bit of that, and suddenly you can find a pound here or there.
Right.
So yeah.
Yeah, a pound isn't a lot.
No,
right.
it's amazingly easy to weigh a pound more. It's surprising. You don't think it's when a bike is a lot of material and just the thickness of the paint on the wheels and things like that. Like it doesn't seem like
or
a
one
lot.
beer for us, right?
Yeah, I know, honestly.
So you mentioned the tank, and I did want to ask you about that too, because one of the things in a race bike we all know where traditionally the tank is up in front of you, and the fuel load changes, and it changes the handling of the bike during a race. Does it do the same thing on the APX-350 MA with the tank behind you? It
does. The majority of the weight of the fuel is more directly underneath you.
It's under you, not behind you, right?
Yeah, some is behind you, but the majority stays fairly low in the tank. And if you're weighing or measuring your fuels and calculating fuel consumption and stuff like that, you can get your fuel level pretty low. I usually tell everybody run a full tank because you can DNF a race running out of gas, but you're probably not gonna not have an issue if you have an overfull tank. So err on the side of caution. But if you want to get really technical about it, you can weigh fuels or drain fuels and do stuff like that and really get down to a very low fuel volume for a sprint race. But yes, if you run a full tank and as burns through it, it will change the center of gravity slightly of the bike. No different than a regular fuel tank would on a regular motorcycle configuration. But you don't notice it that much, to be honest. Though, I've done endurance races with our bikes, not the APX, but the Evo 2 and the GB2, and yeah, it's there, but again, it's surprisingly not that big of a factor since it is surprisingly far forward and down in the chassis.
I was laughing to myself because I'm thinking about when you guys had the test at Crescent, and they were out there, they were doing 1.5 hour and I think 2.5 hour test sessions or practice sessions. And they did run out of gas.
Oh, yeah. No, people ran out of gas. Yeah, because it's just they just kept going and going and going and going and going. I think we did something between 8 motorcycles, if I recall correctly. Correct me maybe if I'm wrong, somebody. But I think it was 8 bikes. It was 1,208 laps or something.
Yeah,
it was. Yeah, exactly. That's what it was.
It was just I was like, wow. I was there. I remember hearing the constant roar of motorcycles. But that was there was something that happened. Yeah, we got a couple got pushed in because they ran out of gas. So
yeah, and quickly back to that test mule. I think I call it a test mule. It's not no disrespect.
No. That's a fair way to call it.
You had Finn Chapman rode it, your test rider. You had Taylor Knapp. Kyle Lowensorg. John Kusinski. You probably rode it. Everybody rode that bike, and it's
Still trucking.
okay.
Yeah. No, Ross Olson, he's one of our
Ross.
Yep,
I
Ross.
met Ross today. Yeah.
Yeah, he's one of our
Ross.
technicians. He comes to the track with us. He also does some of the development riding. He did in between Coda and Barber. We went over to Little Tally to just kind of kill a day and hang out with some of the teams that were there. And Ross was like, "Well, I might as well go ride." So we put him on that thing and sent it around the track for a day there too. So yeah, it's been a little trooper. That thing has got, like I said, well over 2,000 race kilometers on it now, and we haven't done anything to it. Like it's again. You hear that all the time, but in all honesty, like we've just changed the oil and put filters in this.
Does that have steel valves in it still?
It does, yeah.
Oh,
still stainless steel, stock. That thing, we actually, I hate to say it, we haven't even checked valve clearance. So we do that a lot on our development bikes. It's one of those kind of fun things that it's like it's fun to torture test them and see what happens. And we've done it with our 690s and our 890s, where it's just like treat it as poorly as you can treat it within reason. Change the oil, change the filter, and just let it go. And we've proven out how durable some of these drivetrains really are. So
okay, I'm not showing off. I got to ask you this just because I'm curious, because I've worked on some singles. Shim under bucket, not threaded adjusters.
No
Right.
screw and lock nuts in our world.
Okay, yeah.
Shim under. It's a standard KTM valve train in that sense, but yeah, shim under bucket on the 350, and it's real good. So
you gonna put an electric power plant in a Krämer at some point?
I hope so.
You do?
Yeah. No, I think that's pretty universal in our company. When, where, how, I don't know. It's a good question. We've dabbled in it, and we're aware. It's the electric drive side of things and motor controllers and all that stuff is a pretty proven world. And not that there isn't room for improvement there, but it's a pretty proven world. Where the struggle is and where we kind of have to kind of tiptoe around and whatnot is batteries. That's the hard thing right now. Batteries is a hard thing. And so until there's maybe another kind of shift in battery technology at a more reasonable cost level, I don't know if we'll step into that space, because I think that's the big rate limiter. But I think if we see some shifts in some of the battery tech that's kind of out there, then yeah, I would love it. I think it's great. I think somebody who's ridden a proper high power electric motorcycle, and I've had a chance to be around some well sorted machines. It's different, but it's good. It's really good. It's pretty wild, to be honest.
What about a Triumph 675? We get a little Moto 2 action over here.
Obviously we stand pretty close with KTM, but that being said, given the chance, I would love to work on developing a Krämer based, Moto 2 inspired type platform, because in my eyes, it would be a great transitional step for Moto 2 as it stands. So.
Yeah, and I think it would obviously be beneficial for a guy like Cody Kopp that's really just too big for what he's dealing with.
Yep. Yeah. And then I think we have our GB2 family, which uses the 890 platform from KTM, and that chassis works really well. It's really well developed at this point. We ran in BSB the last 2 seasons, got the championship last year on it with it, and the bike works really well. That drivetrain, the Triumph drivetrain, is one that's been very interesting to us. I've been around them quite a bit personally, and it's a pretty well developed drivetrain at this point. It's got a lot of updates that have been really good. But yeah, right place, right time. I definitely get a vote for me. I think that's one of the fun things as a company is that we are able to do more, offshoot projects and things like that. So
how does that work? Like, you pick up the phone, you call somebody at Triumph and said, "Hey, what are the chances of getting 20 of these motors?" Is it like, "Oh yeah, we can make as many," or are we like, "Oh man, we're tapped out with Moto 2 and we couldn't do that," or you haven't got to that point?
I haven't had those conversations to be honest, but I know in the industry that business is business. People want to sell stuff, so I have fairly high confidence that part of it wouldn't be a problem.
Yeah.
It's a lot more complicated than that, of course.
Right.
But for us to go down that path, I don't see it being impossible. That's for sure. And I honestly would push for it internally. What the bike would be and how it would be configured and things like that. And just talking all hypothetically here is up for debate, but. I would have a ball with it. Work in the business side of it, that's a whole other conversation. But got to make it make sense. But that being said, I think it could be a cool machine.
I was talking about the design language of your bikes a little bit, and the fact that it's funny about the Talent Cup bike, and then I see one of your other bikes, which you guys often have. You may have one here, and I'm like, oh, that's the other bike, and you can tell it's bigger. So aside from design language, and I'm not sure if I'm using this right, maybe geometry or is the configuration of the steel trellis frame the same across each bike, and you just make it bigger, upscale it?
No, interestingly, that's one of the things that's kind of unique. The bikes change a lot as you go to different tire sizes, in a general sense. Going from a 180 to 190, no, it's not. But going from a 140 to a 190, the behavior, that's a lot different. And so how the bike needs to be configured with your base front end geometry. We can talk about like general targets, like just trail number. That's a fun one always to refer to, because it's a number that you can look at motorcycles and kind of give a range and say, as little as like maybe 85 mil ground trail up to like 110 mil ground trail as a motorcycle you could at least ride. So there's a safe generality to all that, but in between those numbers, there's a lot of nuance. So like with the Apex, our ground trail numbers are going to be more in the low 90s, potentially in the mid 90s, and we can push it over 100 if we want. I think technically with very little adjustment in fork height or ride height, front ride height, I should say, we can tune rear ride height and offset and rake angle. I think we can go as little as like 85 or 88 mil ground trail up to like 105 or 108 or whatever it was. So like there's a lot of room for what can work or not work. Now when we look at our Evo 2 or our GP2 family, the Evo 2 is a little bit more slack. It's got a steeper head angle. It's a little bit more stable. It's a longer wheelbase. It's a bigger bike. So that bike is just generally more stable. And it kind of, you can feel it. The GP2, numbers wise, it's a little bit more aggressive than the Evo. We did that intentionally though, but the GP2 family carries the same adjustable rake angle as our Apex family, so we can do plus minus half or plus minus 1 degree of rake angle in the chassis on that bike. So we don't build them exactly. It's not a copy and paste and just drag the corner and scale it up.
Right.
But
I
wish it was that. Yeah, I wish it was that simple.
Well,
but yeah, how they behave with the roll of the tire, the change in diameter of the tire as they lean over, all that plays a really big factor. And so like I don't like to ever say there's absolutes. There's generals. I could say a rake angle of 23 degrees or 24 degrees or whatever the number might be is a reasonable number, but we can get into a lot of nuance when we start talking about pivot shaft height and swing arm angle and all that.
Okay, let's go the other way for a minute. Would you guys ever do a mini cup bike?
That's harder. Yeah, I want to. I would want to build one of everything, to be fair.
Right,
like
sure
if it was up to me and I just green light every project we want to do, like let's go for it. It's just constantly doing development because that's what I like doing. The business sense of the mini cup is hard.
Okay.
Not because I don't think we could build a really rad mini. I think we could. I think there's a space there to build a really cool one. It just would be really expensive. And that's the hard thing. I can very confidently say we could build a really cool mini.
A really cool one should have a 2-stroke.
I would not. You would not hear much pushback from me on that one, honestly. I would love a well-sorted 85, to be honest. A well-sorted 85 would be my kind of go-to target, maybe even a 65 base platform.
Teach these kids how to ride a
yeah,
500, right?
Yeah, exactly.
Did you used to race a TZ?
No, not me personally.
Okay.
I've been on them,
Okay.
but not with any real gusto.
You raced though.
Yep. I did a bunch of different club racing. Never raced with MotoAmerica or MA, but club racing level for sure, personally, and then of course a lot of track days and things like that.
Yeah,
so.
the bike from engineering a point of view as well as a rider, which is some engineering as well.
Yep.
So
yeah, and then I think it's fun to kind of come at it with that perspective sometimes. I don't get to ride anywhere near as much as I used to. It's it's a cobbler's kids go without shoes type situation.
Yeah,
I think on that one
exactly.
a bit. But yeah, no, I still get a chance to get out every so often. So,
Yeah.
So yeah.
That's cool. Final question for me is the logo. And I'm not talking about the logo type. I'm talking, is it a shield? What is it?
It is a shield.
Okay.
So Marcus Krämer probably talk more to that, but one of the big things kind of in Germany, is everything kind of has like a crest or a thing. And so his hometown even has like a local crest and a shield. And like there's a lot of old culture that's derived from that. And so the shield is kind of coming from that subculture. And there's two types. There's the old shield, which I think is the hat I have on, and then the new shield, which is just a little sharper and pointier, which you'll see on our other marketing and advertising. And then we have our old logo, which is a little simpler, than our new logo is a little bit more swoopy. It's just kind of leaning into the German culture a little bit in that sense.
That's cool.
Yeah.
That's the way it should be.
Mm-hmm. Yeah.
And your background, you're Finnish?
I am. Yeah. My family on my dad's side is a Finnish. So last name Karvonen. Yep. And so for better or worse, I'm not sure which on that one. So
somebody in our group thought your name was Karvoninski. And it's like, no, it's not.
There's a little extra number, letters in there to get to that one. Yeah, I was say, that was tough enough.
Yeah.
So.
Well, thanks for being on with us, Joe.
Yeah, it was great.
The series has been terrific so far. I mean, what you guys have done with that bike and really the entire series, we're looking forward to it and hope it keeps going for years with us. And it's great to have the relationship.
Yeah, no, it's been great, and thank you for the time today.
Thanks for joining us.
All right.